atom and the periodic table. And so let's go to this slide right here, and we're going to start first of all with an element versus an atom. An element basically is a substance that cannot be broken down into a simpler substance, and that's the definition of an element. So where you find these items are on the periodic table. And if you look in the back of your textbook, you have that chart that displays all of the 100 plus elements that are known at this time. I believe there's over 120 plus in there that are definitely identified. Now, an atom is actually very similar to an element. It is the same component, but I like to phrase it as the counting units. Let's say I have an element, let's say a pencil. We're going to call the pencil an element. And I grab 5 of the identical pencils. And how I would classify that is 5 atoms of element, the pencil. So it's a counting unit of that element. Okay. Now there are 3 subatomic particles that are found of an atom. The first one is a proton. And when you visualize this, think of the P for proton. Protons are positive. So P for proton, P for positive charge. Okay. Neutrons, if I look at this and cut most of the root word for neutrons, are neutral. So you can almost see the word neutral in the word neutron. Okay? And basically a neutron has no charge. They're kind of a filler component that's found in the atom. The electrons right here, think of the E for electrons, are negatively charged. They're negatively charged. And they're located on the outside of an atom. Okay, but these are the 3 big components. Now, when we look at this, the nucleus is the center of an atom. They are the center of the atom right in here. And the items that are located in that center are the protons and the neutrons. They're the bulk or the mass of that atom. Okay? Now, you also have these electrons, and these electrons are going to float on the outside. And where they float are these in those rings, and those rings have 3 possible names. It could be classified as an energy level, or a shell, or an orbital. But those are where the electrons are actually located, and they have very little mass. They do have mass, but it's very small. Now, let's start with the first one up here, the atomic number. And the atomic number is classified as the number of protons an element has. Okay? And where you identify that atomic number is this thing right here, that top number that's in the block. Okay? And that identifies the number of protons that are present in there. But there's a secret. So if you know the number of protons, you also know the number of electrons as well. So if there are 8 protons in this oxygen atom, there are also 8 electrons that are floating around. Okay? Now, the mass. The mass, as we had said before, is the bulk of the amount of stuff that's found in an atom. And the predominant amount of matter or stuff that's found in the atom is basically your protons and your neutrons. And so this magic big number that's on the bottom, that even has a decimal, that one right there is your mass number, and it's a combination of protons and neutrons. Okay? And typically what we do with this particular number is we're going to round it to the nearest whole number in order to do some calculations. Okay? Now, just to recap on here, The atomic number, remember, is found at the top. We have our symbol, which the first letter is always capitalized. The second one is lowercase. And then you have the name. And then the last one is your mass number. And it's usually a decimal because it is an average of all the possible mass weights that that element may have. So where do you find these items? So if you want to find the number of protons, then you look at the top number, which is also your atomic number. If you want the number of electrons, you're going to go back and you're going to refer back to that atomic number as well, which is your number of protons. Okay? And then if you want the number of neutrons, then it's your mass number minus the atomic number. Because remember, your mass number is protons and neutrons. Okay? So it's protons plus neutrons that are in there, okay? So in order to find it, and remember your atomic number is just protons. So you're going to subtract those protons. If you take the protons away, you're left with neutrons. Now let's practice. So the symbol, we're going to start first of all with the symbol. So you look on the periodic table, and neon is Ne. So we're going to capitalize the N and lowercase e. Remember, the second letter is always lowercase. Neon, when I look at it, the top number for neon is 10. Okay, is 10. Make that a little bit bigger. Your mass number is the one on the bottom. I'm going to go ahead and round it. And when I round it, it rounds up to 20. Okay, and then your number of protons it is your atomic number. So if you know your atomic number, you know the number of protons and you know the number of electrons as well. Okay. Now to find your neutrons, we're going to subtract the mass number minus the atomic number, which is also the protons. So if you do the mass number minus the protons, 20 minus 10, you get 10 neutrons. Okay? So let's look at boron. Boron, the symbol is B. The atomic number, when I look at it, the top number is 5. And the mass number, we're actually going to round it, and it rounds up to 11. Okay? So the protons and electrons, remember, are your atomic numbers, so it's going to be 5 and 5. But to find your number of neutrons, you're going to take 11 and subtract that atomic number 5 from it, and you get 6. Okay? All right, now an isotope basically is a variation of that element where it's going to change and alter in its mass. And the big component that changes within an atom to create isotopes are the number of neutrons, a change in that neutron. If you change the number of protons, then you're looking at a totally different atom. Totally different atom. But in order to create an isotope, you're basically either adding mass or taking mass away, and the biggest way to do that is through your neutrons. And here you can see with the carbon-12 versus carbon-14 diagram here, we have 6 neutrons here, but on the carbon-14, you actually have 8. You're adding 2 more in there, okay? So when we look at this one with oxygen, your number of protons, when I look at that one, oxygen has 8, so I'm going to write 8 all the way down. And so the variation, when I look at this one, oxygen 16, that's your mass, so you're going to take 16 minus 8, and you get 8 neutrons. Now, for oxygen 17, we're going to subtract 8 from that one, and you get 9. And then 18 as your mass right here, you're going to subtract the 8 from it, and you get 10. So the only item that changes in an isotope is your number of neutrons. Now, I'm going to give a little history with the periodic table. The periodic table was basically designed by Mendeleev, Dmitri Mendeleev, and basically he designed his periodic table by increasing atomic mass. But he did realize that it didn't actually increase. There were a couple of elements that decreased with the amount of decreased in its mass. But then later, this guy from England, his name is Henry Moseley, he looked and re-examined the look of the periodic table and realized that he could arrange it by increasing atomic number. And that's how currently when we look at the items here, or the periodic table, it is by increasing atomic number. Okay, now there are some components and parts of the periodic table. Rows go across, and they are called periods. Okay, and that's the technical name we need to get familiar with. So periods go across, and columns are your groups, or they can be called families. So your columns go up and down, rows go across. So in looking at this, there are 7 periods on here, and I'm going to label them 1, 2, 3, 4, 5, 6, and 7. Now notice these two down here. They're color-coded with these two right here. So they're actually continue with this scheme, but if I place them up there, that periodic table would be much longer than it is. So in order to consolidate it, they just brought part of it down in order to squeeze it all into that space. Okay, so there are 7 periods when you go across, and elements that basically are placed in the same periods, they basically have the same number of rings, or those energy levels, shells, or orbitals. So all the elements in this first row have only one orbital, or one ring. Those in the second row have 2 rings, and so forth as you go down. And the one in the last row right here has 7 rings you're going to draw. We'll get to those later. Now groups, there are 18 groups through here, listing it from 1 over here all the way to 18. And there are your columns. And all the elements that are grouped in the columns, they all have very similar properties. That's why we call them families as well as groups. But they also have something called a valence electron. And valence electrons are those electrons in the last shell. And we'll get to oxidation numbers later. Okay. Now, a valence electron, as I said, are the number of electrons found in the outermost energy level. And if I were to go back to this column and label it, the code on here, we're basically going to work with just the ones in color. This one is 1. This one would be 2. The one in yellow is 3. This one is 4. This one's 5, 6, 7, and then this one's 8. And basically what it means is that tells us how many electrons are found in the very last outer shell. Okay? And it's usually, when you look at it, it's the number next to the letter A. Okay? And just to help you, because there are Roman numerals, that this is the codes for the Roman numerals, just to help out. Okay? And that's where we're going to stop for this video presentation for now. Okay?